Okay, this is the recording for checkpoint 4. We will go through both the actual checkpoint and also the bonus questions. Right. So first one, we start with the denary to hexadecimal converter. So write function denary to hex to convert a string of denary numbers to a string representing a hexadecimal number. So for this, just note that the input is given in the form of string. So we need to do an initial conversion to int type first. Okay, so I just will copy paste this and then just put it into my cosmology. Okay, so this is question one, right? Okay, so this is what I'm going to do. Okay, so usually what I do for this question is that I like to use a helper function that will settle all the hexa conversion for me. Okay, so usually I'll just call it a hex converter, hex convert. Okay, this will take in a number, okay, and then return accordingly. So if this number is less than 10, I just return the string of the number. Okay, string because later with the hexa type has to be hexa number is returned as a string, so return the number. Okay, and then what I'll do is that, okay, I forgot to do this. Okay, what I like to do is that I usually don't use a dictionary. So if you want, you can use a dictionary. I'm just, okay, for ease of explaining, I use a dictionary here. So let's just set up dictionary. So 10 is equal to an A, and then so on and so forth. I'm just going to copy paste this and then just replace accordingly. Okay, how many do I have? Okay, so this is 11, 12, 13, 14, 15. Okay, and then substitute the letters B, C, D, E, and F. Okay, so we can use this dictionary. Right, so once I have that, I can continue by this code here. So if it's larger than 10, I'll just else return dictionary of the number. So let's just quickly test this function, make sure everything's working. So hex convert 9, I'll get 9, and then hex convert 0, I'll get 0. Hex convert 11, I get type error, typo. DCT, yeah, should be square brackets. Okay, so square brackets num, okay, and check. Okay, so this is what I have lah. So this is what I want. Alright, so this is fine. So I can use this easily. Okay, so remember for hex, for first thing first, let's convert our string into a num first. So string equals to integer num, oh no, what am I doing? Num equals to string in, right? So once converted that, right? So I will remember the method is that I'll keep on dividing. Until the number is less than 1. Goes less than 1. Yeah. So let's just check. Okay, so let's put the answer first. Let's say the answer equals to empty string right now. Okay, so I'll do while number is still larger than 1. Okay, I will do this, right? So I will do remainder equals to num. Since we're doing hexa, we divide by 16, we modulo 16, then we will do add into it. So answer equals to, use the hexa converter now, hex convert, okay, remainder plus answer. Add at the front, because remember the last, if you do your division method, right? The last remainder to come out will be the first one to go and read outwards, right? Okay, then we will divide our number by 16. We will do a floor division. Num equals to num floor 16. Okay, then here, right, once it ends, right, there's actually one more number outside. So we still need to add that into our list. Let's just check using some of the test cases and see what we get. Okay, let's look at test cases. Maybe let's take 2, 4, 5, 9. Okay, because this is, maybe take a simple one first. Let's see how it goes. Okay, let's put it into here. Alright, then we just return answer first, see what we get. Okay, type error. String object is not callable because it should be string str. Okay, let's try. And then instance not supported between instances of string and int. What am I doing? Yeah. It's a problem. So it should be in string. We get A, this is correct. Let's just find something else. 2459. Let's see whether they get it or not. 2459. Okay, let's see. Okay, should 99B. So it seems okay. Let's test a few more cases. Maybe let's test with 51962. Okay, and run it. Okay, 51962 runs kafka. Seems correct. So I'm just going to copy paste this into Cosmology. If you're using a helper function, do paste your helper function in as well. Otherwise, Cosmology won't recognize it. Okay, Control V, and let's run this. Submit. Okay, seems alright. Okay, so this is fine. Question 1. Okay, question 2 is not in your actual checkpoint. This is a bonus question. Let me just reset the answer so that you can do it together again. Okay, so convert in to bin. So straightforward. Okay, into bin conversion. Let's put this as question 2. Q2. Okay, into bin. Into bin, straightforward. We can basically use this structure here. Okay, so I'll type it again. So same thing. This one, x is given in the form of integer, so no need to convert. Okay, so again we have an answer. Answer equals to empty string now. So while x is larger than 1, okay, I will do answer equals to do string x modulo 2 plus answer. Okay, then answer, then x equals to x slash 2 floor divide, then return answer. Let's just check with some cases we know. So in to bin, let's do maybe 0. Okay, 0 is okay. So you see right now, right? Even 0, if you convert 0, right, you should be returning 0 inside, right? So because remember, binary 0 is just a binary 0. So let's check 1, see what happens. 1 also same problem, because I think we are not returning, because when we are dealing with small numbers, right? This numbers here don't trigger this test cases, as in this test condition. If we take 2, we should be able to get see, when we take 2, right, we should get 1 0. So we are not adding one more round answer here. So what I need to do here, right? Actually here there's still a remainder, there's still an x left over, right? So there's still one last step here. So your answer equals to string x plus answer. Okay, let me check now. You should get 1 0, that's fine. Let's take a number we're trying just now. 0 is also still 0, and then 1 is still 1, and take a bigger number, let's say 8. 7 should return us 1 1 1. Okay, I think that's fine. Let's just copy paste and put it into Cosmology again and submit answer. Okay, so should be okay. Okay, so question 2. Okay, question 3, converting to scientific notation. So this is the standard form. 1 2 3 can be converted expressed as 1.23 times 10 power 2. So I will write one function to the first one is to retrieve the power. Okay, so this task A. Second one is to retrieve this 1.23. But note that task A, right, they want you to write a recursive program. Okay, so be careful. If you don't write the recursive way, you get 0 for all this part. Okay, so let's take this case here. Control A, Control C. Okay, B. Okay, this is question 3. Okay, so before we do anything, let's just look at here first. If I have 1 2 3, this is 10 power 2, because I can divide. If I will keep on dividing until I get a number that is less than between 1 and 10. Okay, not more than 10, right? So if the number is less than 10, right, I'll just return 0 straight away. Okay, so that will help us. Okay, so let's try that first. Control Shift. Okay, so I haven't copy paste the code. Okay, Control A, Control C. Okay, then go to here and run it here. Okay, so power test. First thing I check if k is less than 10, I'll return 1. I'll return 0. Okay, because 1 to 9.9999, right, is still power 0. Okay, so just return 0. Okay, so else, what should I do? Else, right, what I do is that I will divide 1 time first. So every time I divide, I will add a 1 inside. So return 1. Okay, then the recursive call happens here. So power 10, and then I just do k divided by 10. Right? So let's check whether this is working or not. That's all it has. So this is power 10. What am I typing? Power 10, maybe 11. I get power 1. So 11 can be expressed as 1.1 power 1. That's fine. So 1, 2, 3, power 2. Alright, so that's okay. Okay. So for the next one, write another function significant 10 to return the significant. Correct the 2 decimal value in the scientific notion. So this one, they never indicate that they want it to be recursive. So I won't write it recursive. So you can try it if you want to write recursive lah. Okay, so significant k. So keep on dividing until you get a number that is less than 10. Right. So this one, so this number here, because of the condition here, right, they tell us that the number here is 1 to 10 already. Okay, and then they do not take in any negative numbers. Right. So positive real number equal to greater than 1. Okay, so you won't need to deal with anything less than 1 lah. Right. Okay, so while k is, okay, sorry, if k is less than 10, you can just return straight away, return k. Right, so that's fine. Okay, but we return rounding lah, return round k comma 2. Okay, so let's try this one. So significant of 10. Okay, I think what's happening here? K less than 10, return round k2. K less than 10. Okay, because it's not captured by this, so 9.999. Okay, 9. Okay, so just return 9. Yeah, so this is fine. Okay, so let's just check this. I realize there's no. If I do 9.009, 9.09, I think it's okay. Yeah, there's something weird about this one. Okay, let's leave it for time being lah. Okay, so else, okay, I'll keep on dividing. While k is more than 10, more than or equals to 10, I'll keep on dividing. Okay, k equals to k divided by 10. Okay, at the end, just return round k comma 2. So check number, let's take maybe 909 instead. Okay, I get 9.09. So 123.45.456. Okay, 1.23. Okay, so we put this in. I think it should be okay. Let's test this one. Any test cases fail? Let's see. Should be okay. Yeah. So this question 3. Alright, we're looking at question 4 now. Question 4, sum of numbers. Okay, write a recursive function sum num that takes in positive value n larger than 0, consists of the number from 1 to n. If the number is divisible by either 2 or 3, include the sum, otherwise leave it out. Right, so we will let it, okay, so we can this one needs to be a recursive, right? So we can think of which condition to catch first for the terminating case lah. Okay, so for terminating case, maybe we need to think a little bit more. Okay, so Q4. Alright, so let's put this in. Okay, so since I'm going to start from 1, right, I can just catch from 1. Okay, so I can catch if n equals to 1. This is the problem that you might fall into. You might return n. That means return 1. Okay, but you don't really want that, because remember, the question says that if it's only divisible by 2 or 3, then add the sum. Otherwise, leave it out. So 1 is not divisible by 2 or 3, right? So we should return 0 here. Okay, return 0. Okay. So once I have that, right, then I can go on. I can write the rest of the case. So now I do the else condition. Okay, if n, okay, I'm looking for can divide by 2 or divide by 3. Okay, so I got one interesting error just now. So if type n divide by 2 equals in. Okay, this sounds legit, right? Because if let's say 4 divided by 2, it will give you 2 as an integer, right? But do remember that for Python, right, division, right, will always give you a float. Okay, so say for example a equals to 5. Okay, I equals to 4, b equals to, okay, you do type of 4 divided by 2. Clearly this one will not give you remainder, right, but I still give you a float, so you cannot use this method to check. Okay, so we need to use our modulo instead. So we do if n modulo 2 equals 0, or n modulo 3 equals to 0. Okay, so if either of these conditions is true, it will trigger. So if it's triggered, that means I need to add that number in, right? So return n plus the recursive call now. So some num. Okay, some of you like to complicate this by saying, oh, if it's divided by 2, then the next because can divide by 2 is an even number, so you do some num n minus 2. But you realize that this one is a bit harder to do, because a number that can be divided by 2, right? If you skip past, because let's say for example you have 4, you skip down to 2, okay, but then you have skip 3 will actually trigger this condition. So you need to keep this one here lah. So don't bother dropping by weird numbers, just drop by 1, that will do. 1 is always safe lah. Okay, then if cannot be divided by these two numbers, right, I will just return. Okay, I just put a 0 there. I don't have to put the 0, but I just put it for clarity. 0 plus some num and minus 1. Okay, so let's take a few test cases to test. Let's take maybe 7. Okay, 7 and see some num 7. Okay, and we get 15, so that should be fine. Okay, so let's just copy paste string into here and submit. Okay, we are done for this one. Okay, then let's look at question 5. Question 5, character swapping. Okay, character swapping is a bit more interesting. I will not do. Okay, let's do 5 now lah. Okay, so 5, right? I'm supposed to swap them if the last letter is bigger than the left letter is bigger than the right letter. Okay, it starts compressing the first 2 characters to decide whether they need to be swapped. If the first character is bigger than second, then swap, otherwise they're not processed. After the swap, the smaller character is now considered processed. This first character now is the one that shifted to the front. Okay, remember, let's say you're comparing x and y and x. Okay, so you're comparing y and x, right? Now after you swap them, right, x becomes the first one, right? After their swap. Okay, then now this portion is still unprocessed. Okay, so recursion should be applied on the unprocessed string. So what's happening is that, for example, let's say I look at this one that's more complicated. So the first one here, let's blow it up a little bit more. Okay, so let's look at this guy here. If I compare x and y first, right, z and y, I will swap. Okay, once I swap, right, I will keep y here. I will compare against the next 2 characters. Okay, so on and so forth. Okay, so it's a bit more tricky lah. So let's just do it slowly. Okay, let's take this down and then put it here. Okay, so let's take this and put it here into question 5. Q5. Okay, so swap. Okay, so maybe what we can do is to look at more test cases. Let's take this y, x, w. Okay, what we're trying to do is that we are trying to do something else. Let's put triple quote. Okay, we start off with this. Oh, sorry. Okay, we start off with this. I will compare the first 2 first. Okay, so the first 2 is we swap, right? If we swap, right, it will become y, z, x, w. So once I've done that, I will compare the next 2. Z and x need to swap. Okay, so y, z, x, z, w. Then the next one will be y, x, w, z. Okay, maybe you find something that's a little bit more, this one, y, x, z. Okay, so this one here, y, x, z, right, is a bit more interesting. Y, x, z, if you look carefully, right, okay, so the first one, the first swap does not happen, because y is still smaller than z, so it doesn't happen. So y, z, x. The next comparison happens here, and then you have to swap it, so you get y, x, z. Okay, so you have to be very careful about this. Okay, so let's do this first. Okay, so if the string is less than 2, there's no comparison to be done. If it's a single character or 0, right, I'm just going to return the string. So that means if len string is smaller than 2, return string. Okay, and done already. Okay, so now the comparison. So let's do the comparison. Okay, so let's say we have to do the swap. Okay, so if string 0 is larger than string 1, okay, so I will swap them. Okay, how to swap them? Okay, so once it has been swapped, right, the one that is that has already been the one once you swap, right, the left character is considered to be processed A. So in this case, right, string 0 larger than string 1, right, that means the second there's a swap happening. So I'll return, okay, return string 0. So string 0, string 1 basically takes the first place already. Okay, then plus what? Okay, now this is the recursive call. Remember 0 and 1 has swapped, right? So my string now has become, my new string has become string 1 plus the rest of string from 2 onwards. Okay, so this is the swap car part. This is a recursive call on string 0, okay, plus string 2 onwards. Okay, so because 1 and 2 has swapped. Alright, okay, then next one, now I do the else condition. Else, right, there's no swapping happening here. No swapping happening here, right? So I'm just going to return, okay, no swapping, string 0 stays as string 0, string 0 plus swap car string. Okay, there's no need to do separation like this because 1 is still at the original position. The original 1 is still at the same position. So string 1 onwards. Okay, so let's test this guy out. Okay, so let's remove this and then we do a string swap for something simpler first. Let's do x and y. Okay, let's see. This one probably there's no need to swap at all. Okay, Control Shift V, nothing to swap. Okay, if I swap them around, yx, yx, yx. Okay, now it's swap. Okay, take one that's a bit more complex, maybe yzx. Okay, yzx. Okay, should become, yeah, because yz no need to swap. Okay, xz will swap. Okay, one more, zyxw, zyxw. Okay, so z will traverse all the way to the end. Okay, and then y will y will follow. So z and y will swap, y and z will swap. No, x and z will swap, and then z and w will swap. Okay, so copy paste this in, and then we should be good to go. Let's see, Control V, submit. Okay, yep, so correct. Okay, then one more question. Question 6 is quite straightforward. 6 compared to everything else is straightforward. Okay, modified Fibonacci. Recursive function gx is defined for low input argument x less than 5, return x, otherwise sum the two previous values gx minus 1, gx minus 2, then subtract 2 from this sum, return this value. Okay, so this one is quite straightforward. It's just follow the rules and implement it. Okay, so be question 6, Q6. Okay, so this one don't take too long. Okay, so if it's less than 5, return. Okay, so if x is less than 5, return x. Okay, else return the two previous one, right? Gx minus 1 plus gx minus 2, then minus 2 from the sum. Okay, minus 2. Let's take test case to test. Maybe let's take G10. Okay, G10. Okay, 10, 36, that's correct. So they take G less than 5, I take 3. Okay, can this work for less than that? That's right. I don't think there's any problem. That's right. Yeah, 85. Yeah. So this is done, and then we are done with checkpoint 4. Okay, let's paste this in and run it. Let's see what I can. Okay, can. So yes, I will upload this file into the bonus attempt. Alright, so that's all for this one. Thank you.